Check out this incredible video to review last week's test and help you prepare for next week's required retake. Let's go! All right, here we go with video number 1 for our test review and a practice for the retake. Number 1, these are actual questions right from our first test. Useful for anybody working on these skills. Choose all that are proportional to 6/16. Well, proportional, remember, means that when two or more fractions are in simplest form, they are equal. So one way to deal with this is just simplify everything and see what they end up being. Put them all in simplest form. Okay, so let's get 6/16 into simplest form. If we divide top and bottom by 2, we get 3/8, and boom, right away we know that one is equivalent. 2/5, what happens? We're going to check it. 2/5 to get to 6. We would go 2 times 3, but if we go 5 times 3, remember, if we're going to have factors to get equivalent fractions, the factors need to be equal. And in this case, 2 times 3 equals 6, but 5 times 3 does not equal 16, so 2/5 is not an answer, is not proportional to 6/16. Let's simplify 12/22. We want to be thorough on a problem like this because they're usually scored all or nothing. So let's get them all. We can cut it in half. This is step 1, is usually just cutting things in half. 6 out of 11 does not equal, if I take my example from up here, 6/16, right? So there's no way that's going to work. Let's check out 15/40. Let's take, if I get 15 and divide by 6, the reason I do this is to find what's that common multiplier, 2.5. So if I take 40 and divide it by 16, if I get the same common multiplier, and I do, that means they're equivalent. Same common multiplier means yes, equivalent. So yes on those two, no on those two. Let's check this one out. Do you see this relationship right away? If I start with the larger one, like we did up here, and use the numerators as a division problem, we could also use it as a multiplication. In this case, I get 2. Always start and go in the same order. First, the larger fraction, the second fraction. I end up with the same, with the common, let's get the lingo right, with a common multiplier, common factor. Those are the same, so all 3 of these can be simplified to be equal. Therefore, when in simplest form, that one, that one, that one, and our original are all proportional. And that is it for this one. Goodbye. Welcome back. Here we go with video number 2 out of 7 of these test questions. Here's question number 2. We're supposed to decide for all of these 4 pairs of proportions if they are indeed proportions or not. And we just select true or false. So we have a number of different strategies for checking proportions. We have horizontal factors, we have vertical factors, and we have cross products. So we have three ways to check. We're just looking for what way's the obvious. I think with small numbers like this, it might be pretty obvious just to get a cross product here. 9 times 5 is 45. 3 times 11 is 33. Last time I checked, which was a few days ago, 45 does not equal 33, so that one is false. That's a quick and easy way to check if the numbers are small. Why don't we try something like this just to show you horizontal factors, common horizontal factors. 32 divided by 2, I got the 2 from over there, and 80 divided by 5. If those are the same, they have common horizontal factors, and that would be true. Let's check it out. Common horizontal, side to side. 32 divided by 2, 16. 80 divided by 5, 16. Since they are the same, those are proportional. Good. This one was not. Let's just put a nice X through that. The third one here. Oh, I'm looking back to grade school and I'm thinking, hey, isn't 7 times 6 42? Yes. So if we're going for common vertical factors, so this is the third problem and the third strategy we've used just to demonstrate to you, depending on the proportion, your brain might notice something that mine doesn't. And if you have a variety of strategies to choose from, let's see if 10.5 times 6 is 63. 6 times 10 is 60. 6 times 1/2 is 3, and when I add those together, it is 63, so that's true. They have common or same vertical factors. We can go up or down as long as we're going both up or both down. Same thing here, we can go left to right or right to left, but we got to go same direction both. Let's do, since I have 6 times 3 here, nice and easy. Here's one thing I know. I don't know what 14 times 28 is off the top of my head, but I have a feeling since 28 is already bigger than 18 all by itself, when I take 14 of them, it's going to be huge. In fact, 14 squared is 196, and if I do that twice, that gives me 392, I believe. So that, no way, Jose. Nuh-uh, not today. And that does it for video number 2. Bye, come back for number 3. All right, here we go, number 3 out of 7 questions. This one's simple, just solve for x, assuming this is proportional, and it's a multiple choice question. I've always found the best strategy for multiple choice is just to do the work and get the answer and check your work and then select it. Don't worry about eliminating choices and those kind of things. So all I'm going to do is get cross products here. 15 times x on one side, 6 times 35 on the other. Finish this, 180 plus 30 is 210. Then we're going to divide both sides by the coefficient of x, which that means that becomes 1x, but we don't write the 1 there. So now I have x, and then the question is how many times does 15 go into 210? Well, I know 15 times 10 is 150. which gives me 60 left over. So 15 times something equals 60. If I wanted to check that out, I could go 60 divided by 15, and I would get 4. Then I could add those two factors together, and I get x equals 14. I can check this, simply check, not chick. Check it by going 6 over what I think the answer is, 14, and cross multiplying. 6 times 35, we already know, is 210. 14 squared is 196, but there's 15 of them. So since the cross products are equal, that means my answer is correct. And that takes care of this question. We don't even need to worry about the other 3. Goodbye for now. That was video 3 out of 7. All right, video number 4 out of 7. Here we go. It's just a regular word problem. Remember, is means equal sign. What means the x. Percent means fraction bar. Per means fraction bar. Cent means 100. And of is 75, as we learned in class. And if you didn't learn in my class, this is a good strategy anyway. We're just translating all the words into numbers and math symbols, and we're going around the clock in order. 30 is, there's the equal sign, what percent of 75. If I was writing that from scratch without the visual here, it would go, I say these words to repeat the problem, but then I follow that pattern. 30 is what percent of 75. So for every word I say, there's something for me to write. So it matches up exactly. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Well, 75 is 1. 1, 2, 3, 4, 5, 6, 7. I said seven things. I wrote 7 things. So here's what I notice. 75 times itself and another third equals 100. So 75 times 1 makes 75. What's 1/3 of 75? 25. So if I'm getting 75 times 1 and 1/3 to get to 100 in the denominator, then I'm going to do the same thing with 30. 30 times 1 and 1/3. What is 1/3 of 30? Right, it's 10. So that's like saying 30 plus 10, 40. So I'm thinking x equals 40. Another way to do it, this is finding a common horizontal multiplier, or we could just cross multiply and solve. 75 times x on one side, 30 times 100 on the other side. Divide both sides by the coefficient of x, and guess what? Yes, we get 40. There are multiple ways to solve any problems like this, and if you know multiple ways, that's a great way to check your work. And if you have a favorite that you trust, use it every time, because there's a reason why you trust it. And that is the end of video number 4. Goodbye for now. All right, video number 5 out of 7. This one is very simple and straightforward, so let's keep it that way. I'm going to use a strategy that I know works. 12 is 40% of what? Remember, is the equal sign. 40% means out of 100. Of means we're drawing the other line over here. And what is x? So we're going in the circle. We're going in order. I'm just going to cross multiply. This video will be short and sweet. 1200. Divide both sides by 40. Scratch those zeros off. This turns into 1x. So we get x equals 30. Let's double check my work. If 12 over 30 is proportional, I'm checking my work. Check it out. Have you ever checked your work? It's a great way to see if you're right. 30 times 40 on one side. 12 times 100 on the other. 3 times 4 is 12. I take the 2 zeros. 12 times 1 is 12. I take the 2 zeros. And we celebrate. Yay! So 12 is 40% of 30. Done! 2 more to go. Goodbye. Okay, question 6. This might take a little more than 2 minutes, or maybe not. Here is a wordy question with lots of numbers and a percent sign. And the intention is to see if I can catch you not being careful with your reading. Okay, so let's check this out. Let's go down to the question. What percent turned in the assignment? Well, first let's come up with how many turned in, which is given in the first sentence. So 32 turned in. What's the total? So I have turned in out of the total students, 96. So the 24 really doesn't matter here. What percent turned in the assignment? So 32 out of 96 students. That's not a very good return there. So what percent turned in? Let's go for a vertical multiplier here. Ooh, this is going to be interesting. 96 divided by 32 equals 3. So then the question is 100 divided by this same number gives me 33, and on a calculator these threes would go forever. 33 1/3%. So you could probably see this right away. If we simplify 32 over 96, it's 1/3. And so 1/3 of 100 is 33 1/3. We stick to the fractions because if I go 33 1/3, not decimals, I get 66 2/3. And then if I add one more 33 1/3, I get 99 3/3, which equals 1. So that gets me back to 100. And that's a case where using a decimal is probably a bad idea, but we get the idea. What percent? 33 1/3% turned in the assignment. There is our answer. And that was number 6. Get ready for number 7. Wee-hee! Here's our 7th and final review question using the actual test questions from our first test about proportions and percents. This one is dedicated to everybody that has the habit of showing their work. As you all know, if you don't set it up the right way, it's just not going to work out unless you get super lucky. So let's stick to what we know. What is 64 fraction bar 100 fraction bar 150. If I just set it up how I know is right, then it's easy for me to choose the right answer. So if I take all that stuff I just did in green, that's the ugliest arrow I've made in a while, in a day or two. So what is 64% of 150? That looks like this one. The question does not actually ask you to solve for x, just to find the right answer, just to find the right setup. If I continued with this setup, I would get the correct answer, whatever x might be. This one over here, you might say, well, that one's right, right? It does end up being 42, but is this the setup? No, that's the final when it's all done. That's not the setup. So we want to know what's the step one going to be, and there it is. Did that one in 2 minutes, and I will see you later. Thanks for watching.